Section 10.7, oops, sorry for the bobbly picture. Here, I'll try to fix that a bit. Okay. Section 10.7, circles in the coordinate plane. What we're doing in this lesson is our objective is to really make the connection between the geometry idea of a circle and then the algebra part of a circle. Predominantly thinking about the equation of a circle. Is there an equation that we can write that will give us every point on a circle? So to do that, what we're going to do is we're going to take our circle here, this very first circle here, and we're going to put it on a coordinate plane. We're going to put it on an XY axis. And for simplicity, I'm going to put it on an XY axis with a center at the origin. Okay, so here, my center of this circle is at the point 0, 0. Okay, so now every point on this circle, this point here, this point here, this point here, every point on this circle can be thought of, it's going to have an ordered pair. It would have an XY ordered pair. So let's go ahead and let's just talk about this one right here, and let's give it the ordered pair. Let's say it's going to be an ordered pair XY. I don't know what that X and that Y are going to be, but I do know that for all of these points, doesn't matter if I'm talking about this one, or this one, they'll all be the same distance from my center. So they'll all be the same distance, this distance right here, from our center. And we always call that distance R. Okay. So this X coordinate, so all of these points, like if I was talking about this one here, that distance would be R, this point here, that distance would be R. So every point on this circle is going to have that distance R. And this X coordinate, if we think about this X and this Y, this X coordinate comes from how far over we are, right? Because this is our X axis. And up here's our Y axis. So this X coordinate comes from how far over we are. So how far over are we? Okay. So this distance right here would be X. Okay. So there's my X. And this Y comes from how far up we are. So it's this up right here. So this distance here is our Y. And if you notice here, I've actually made a right triangle. And by using the Pythagorean theorem, I can actually relate the X, the Y, and the R. Because if I take this X and square it, plus the Y and square it, that'll give me R squared. Okay, so X squared plus Y squared equals R squared. So, and that would be true for any point on this circle. Okay, so this is actually the equation for a circle if the center is at the origin. If the center is at the origin, 0, 0, then the equation for my circle would be X squared plus Y squared equals R squared. Okay, X squared plus Y squared equals R squared. Okay, okay. But our center isn't always at the origin. So what do we do in that situation? So I'm going to go ahead and I'm going to look at another circle, but now for simplicity I'm going to put it in quadrant 1. It could be in any quadrant at all, really. Okay, so here I'm going to put my X and Y axis outside the circle now. Really, it could be anywhere. So here's my X axis. Here's my Y axis. What this changes now is my center here is not at 0, 0. So let's go ahead and let's just give, so we match our book. It doesn't matter what variables we use, but your book uses HK. So let's say our center is at the point HK. Okay. So the center of the circle is at the point HK. So again, we're trying to come up with an equation that will give me every point along this circle. So I'm going to go ahead and I'm going to pick a point at random. Here. And again, I'm going to call it XY. Okay. So there's my point XY. Okay, and every point, no matter what point I pick, that point, again, is going to be the same distance from my center. So again, we'll call that distance R. Okay, okay. And we're kind of going to do the same thing as we did last time. We're going to put in, because again, this X coordinate, where's that X coordinate come from? That X coordinate comes from this right here, right? This is my x coordinate, and my y coordinate comes from, I'm just going to do dotted lines straight across. So here would be my x, and over here's my y, right? There's my x coordinate. There's my y coordinate, and we've made a right triangle again. But what makes this different is that this distance, if we're using the Pythagorean theorem, that distance right there isn't gonna just be x, because I'm only talking about this little distance, okay? Whereas I'm already starting this center, if we go straight down, this here is h, right? We're over h, and we're up k, okay? So if we, oh wait, this isn't my y, what am I thinking? That's up k. My y is way up here. Sorry. But we'll draw this right triangle in anyway. We want that anyhow. Okay. So this little distance here would be, okay, it might help if we had some numbers. Here, if I was over 12, if this was 12, hypothetically, just give a number, and this was 7, how would I find this distance? Well, I'm looking for this distance between the two. I would need to take how many from 7 to 12? I need to take the 12 and subtract the 7, okay, which would give me that 5. Okay, so I would have to take this x and subtract the h. So the length of this distance here is the x minus the h. Again, where h is the coordinate of the center. Okay. So now we'll have to do the same thing to find this distance here. This distance here, again, I'm looking for the distance from k up here to y. This distance here. So I'd have to take my y and subtract my k. But now I can use the Pythagorean theorem again, take this thing and square it, this thing and square it, it has to equal. So x minus h squared plus y minus k squared equals r squared. So here is the equation for a circle, okay, but my center is at the point h, okay. So our standard equation for a circle, here, this is our big important thing for this. Our standard equation for a circle is x minus h squared plus y minus k squared equals r squared. With the center of my circle would be located at hk, and my radius would be the r. Okay. So we can use this guy right here to find the equation of a circle. So again, I could graph this, okay, and that would give me that equation of a circle. And we will look at that briefly. I'm graphing using Desmos. These are really hard to graph in your graphing calculator because you can't really write them as y equals something. And that's how your graphing calculator graphs, is by y equals. Okay. So if I want to write the equation of a circle, I need to know two things. I need to know its center, and I need to know its radius. I need to know my h and my k, and I need to know its r. Okay. So if I want to write the standard equation of each of these circles, okay, here first of all we get a graph. So I need to look to see what points do I have on my graph. Well, the topmost point is up here. The bottommost point is down here. So I'm going to connect those to make a diameter because I'm looking for my center. I need to find the center of this circle. So there's one diameter. And it fits nicely across here also. We have this point here and this point here. So if I draw that diameter in, again, diameters have to go through the center. So there, I found my center. My center is right there. So the center of this circle is at the point -5, 1, 2, 3, 4, 4. So there's my h, there's my k. My radius is, well, we can just count. 1, 2, 3, 4. My radius is 4. So there's my r. So I'm going to write my equation, x minus h squared plus y minus k squared equals r squared. And now just plug in. It'd be x minus a -5 squared plus y minus 4 squared equals 4 squared. So now we just simplify. X minus a negative 5, that's x plus 5 squared plus y minus 4 squared equals 4 squared is 16. So if I was to graph this, the easiest way to graph this is to go ahead and put it in Desmos or GeoGebra. GeoGebra will do it also. Oh, that's not how you spell it. Okay, and graph it that way. So let's go ahead. So there's the equation of my circle. Okay, so a circle with a center at the origin, okay, so that would be at 0, 0, and a radius of 2.5. So there's my r. So this is my h, this is my k. So if we put so we have x minus h squared. Notice how I write the equation down again before I plug anything in it. My h is 0, so x minus 0 squared plus y minus 0, because my k is 0. 2.5, I need to square that whole thing. Well, x minus 0, that's just x, so we'd have x squared plus y squared equals 2.5 squared, 2.5 and square it, 6.25. My equation. Okay, last example. Okay, the point 41 is on a circle with a center at 1, 4. So I know here's my h, here's my k. Okay, so I know my center. There's my center right there. We don't know the radius. Okay, but I know if I'm just gonna do a really crude sketch. I know here my center is at the point 1, 4. And then I have the point 4, 1 is a point on my circle, on the circle. So I'm looking for this distance. That would be my radius. So to find my radius here, I'm going to need to use the distance formula because I'm looking for the distance between the point on the circle and its center. So to find the radius, I'll have to use the distance formula. If you don't remember the distance formula, it's the square root of, subtract my x's, square it, plus subtract my y's, and square it. So my distance would be, subtract my x's, 1 minus 4 squared plus 4 minus 1 squared. 1 minus 4 is 3, 3 squared. 1 minus 4 is negative 3. Negative 3 squared is 9. 4 minus 1 is 3. 3 squared is 9. So I'll have the square root of 9 plus 9, which is the square root of 9 plus 9, square root of 18, which simplifies, 18 is 9 and 2, which simplifies to 3, the square root of 2 for my radius. Again, exact, because we can do exact. 3 the square root of 2 is my radius. My center is at 1, 4, so I know everything I need to know now. X minus h squared plus y minus k squared equals r squared. Oops, excuse me, might not have been able to see that. So x minus, my h is 1, y minus, my k is 4, and then I want to take 3 root 2 and square it. So 3 root 2 times 3 root 2 gives me 9 root 4, which is 18. 9 times 2 is 18. So my equation, x minus 1 squared plus y minus 4 squared equals 18. There's the equation. So this one had one extra step. We had to use the distance formula to find that radius. Okay, have fun on your practice.